by word again. Oh man, your head's always in it. Here we go. Just lean forward. If you stay as close as you can to the table, we'll be good. Yesterday I had to re-record because it was like all.
It's his first time.
Okay, so amplitude, period, midline. Someone amplitude in your own words without just like reading it to us again. How would you describe the amplitude of the graph? Brandon.
The amplitude is how far away you can get from the midline, pretty much. Like the maximum minus the midline.
Cool. This distance and this distance that are always the same on the graph, or for the cosine wave, this distance like that, right? Cool. All right, so that's the amplitude. The period, any takers? Deanthea? So basically, if this is labeling like how tall, like the sine function goes up to 1, so the amplitude's 1. The period is the opposite. We're talking now about how far on the x-axis, what is this value right here before it starts to repeat again, which for a normal function, sine and cosine is 2 pi, and then we saw yesterday that that starts to change as we horizontally compress and stretch, okay? And then, last, the midline, Kennedy.
The line that designates the middle of a function is graph.
Cool. So on the normal function, that's the x-axis, y equals 0 is right in the middle. But if I shift it up or down, then that's going to shift up and down and be kind of this imaginary horizontal line that cuts our graph in half. Okay? So it's the horizontal axis of our wave, the middle of the graph about which it oscillates or fluctuates up and down. Okay? Cool. Those three things we saw changed when we put numbers in here for A and B and D, right? So let's really quick recap what A, B, and D impacted, which of the three that they each impacted. So if I put an A value, if I say 2 sine of x, Sandy, do you remember which of the three that changed? Did that change the amplitude, the period, or the midline? The amplitude. So if it was 2 sine of x, instead of going up to 1, now we had it go up to 2 and down to -2. Okay? Next up, B. If I say sine of 2x, any takers for that one? Lirio? The period of the graph. That did not mean that it went to 2. That meant that there were 2 waves within our old 2 pi interval. Okay? And so if there are 2 waves that fit inside of 2 pi, now our period would be 1 pi, right? The length for a wave would be 1 pi. The period would be pi. And then last but not least, the period, running out of markers, there we go. I mean, not the period, the D value is not the period, it is the what? Midline. So if we shift up and down, then that number is going to represent the new middle of our graph because it started at 0. So I shifted up 2. Now my horizontal axis is going to be at 2. Okay? All right. So using all of those things, today is going to be all about looking at some problems that are very similar to the ones on your problem set and pretty similar to what you're going to see on your quiz on Friday. So just like a good practice day of doing this. So you can come back to, I'm going to, for the sake of time on a Wednesday, skip the matching and go straight to like when we're doing it by hand so that we make sure we get to a lot of these examples. For this matching activity, later if you want just practice looking at graphs and equations and making sure you can figure out which one is which, you can come back and match any of those up and practice that. But I want y'all to flip to where it says graphs of sinusoidal functions, this little box right here. Alright, so we're basically going to be filling out what I have on this big pink poster up here that I'm going to be referencing a lot this unit, which talks again about A, B, and D and how we can use those to find our amplitude, our period, and our midline. So for the amplitude, we just shared that that was whatever that A value is. So we're going to call the amplitude the absolute value of A. Because if it's 5 or -5, we're going to still say that the height of the wave from the midline to the min or the max is 5. We talk about distance in positive numbers, right? You would measure with a ruler and it would be a length of 5, not -5. So we're going to say the absolute value of A. For the midline, we just said that comes from D, and so that is going to be an equation of a line, y equals whatever that D value is. So the amplitude and the midline are nice because we literally just like pick them out of our equation. If you look and you find A and you find D, then you've got your amplitude and you've got your midline. The period is the one that I talked about right here that's a little different. When I had sine of 2x, that's my B value, but my period didn't end up being 2, right? That 2 meant that I had 2 waves, okay? And so my period is not equal to B. My period, the way you're going to find it is by doing 2 pi, our old total, divided by whatever that B value is, okay? So in this case, I would do 2 pi divided by 2, absolute value of 2, and that would give me pi, because those 2's would cancel, and that's why we saw that we ended up at pi. Okay? So to find the period is going to be kind of the one that maybe is a little trickier for our brains to think about. For our period, we have to do 2 pi divided by b, and that'll give you that new distance for your wave. Alright, so let's go ahead and jump into the first example. We're going to do one together, then y'all are going to practice 3 of these, and then if we have time at the end, we're going to go the opposite direction, where instead of giving you an equation, I'm going to give you the graph and you're going to have to write the equation, okay? We're going to be able to go back and forth between these. So take a look, you've got a function, f of x equals 5 times sine of 2x plus 1. You've got an a b, and a d value that we have to deal with that's going to change what this graph looks like when we graph it right here. So let's go ahead and find these characteristics and then we're going to draw our graph. So from the top, we've got our amplitude. Our amplitude should be super quick to find because it's just absolute value of A. So everyone really quickly write down what you think the amplitude would be looking at your equation. Eli, coming to you. What did you say for A?
5 times
Yeah. So it's just 5 from that part of our equation, right? Okay. Next up, the period. I just said that is not B, it's going to be 2 pi divided by absolute value of B. So we have 2 pi divided by 2, and that is like the same as the example I talked about, where you're going to get pi. Pi, which means our wave, one cycle, one rotation of a wave, no longer goes all the way to 2 pi, now it only goes to pi. Okay, when we label our x-axis. Next up, the midline. Orange, we'll do orange. We said the midline is an equation, y equals d. So in this case, that would be y equals 1. Not that bad. Okay, for our minimum and our maximum, we can think about it and kind of do the math, but I think that the minimum and the maximum come really easy once you graph it anyways, because you just see where the top and the bottom are, and we can write them down. So let's kind of now go ahead and start sketching our graph, and then we'll finish off our min and our max. When you're graphing this, you could start with like the amplitude and start thinking about, okay, it goes up 5 and down 5, but then as we shift around, depending on what order you go in, it can kind of get a little bit confusing. So one way I like to remember to draw these that I think has been the most helpful for people today is to think map. That's an easy thing to remember. And that means let's start with our midline, then think about our amplitude, how much we go up and how much we go down, and then finish by thinking about how wide it is, what is our period. That's an easy way to kind of like order the way you're sketching this, okay? So we're going to draw our midline, the first part of map first. Where's our midline? 1. So everyone go draw 1, a little dotted line. to show that that is going to be that new horizontal axis, the middle of our graph, about which our wave is going to oscillate up and down. Leo, you with us? Okay. Midline. Next up, map. Amplitude. That means since our amplitude is what? 5, we need to go from 1, we need to go up 5 and down 5 to get the tops of our wave and the bottoms of our wave. So I'm going to go up 5, 1, 2, 3, 4, 5, and I will be up here at 6. And I'm going to draw a dotted line up there at 6. That's going to be touching the tops of my wave. And I'm going to go down 5, 1, 2, 3, 4, 5. And I'll be down here at -4. And that's going to be the bottom of my wave. So yeah, Melanie, can you say that a little bit louder?
So that's your min and max.
So that's why I kind of like to then go graph it, because once you graph it, that's an easy way to find your min and max. You could also find your min and max, so that's y equals -4 and y equals 6. You could also find it by just always taking the midline, 1, and adding 5 and subtracting 5, right? But I wanted you to kind of visually see why we'd be adding 5 and subtracting 5. That's what we just did. Yep.
Have you ever had big numbers?
You might. I mean, I probably won't give you like plus 100, because then you'll just be like floating way up here at 100. But I mean, like, can you have that? Technically, yes. They could be big numbers or small numbers, but you're going to see most of them probably no bigger than probably like 10 or so, probably. Okay, so when you're drawing these graphs, remember our graphs? We learned 2 functions. It could either be a sine wave or a cosine wave. Sine waves start at the midline and go up and then go down below. Cosine waves start up at a maximum and go down to a minimum and back up to the maximum for one cycle. Okay? So what type of wave do we have here? We have sine or cosine? Sine. So that means for this one it started at 0, but you're starting at the midline, right? So we want to start for our graph, that means at 1, not up at the top at 6. Our choices are either to start at a maximum or start at the midline. For sine, we're going to be starting at the midline. Okay? And then the sine wave generally looks like this. It goes up to the maximum 6, back across the midline, down to the minimum, and back up to the midline, and then it just does that over and over and over. All I need from you guys is for you to draw at least 1 full cycle. So you are welcome to keep drawing wee over and over and over, but I need to see at least 1 full cycle of the wave, okay? And the reason I need to see 1 full cycle of the wave is because that is what we call the what? Period. And so I need you to label on the x-axis, just like we labeled 6 and -4 on the y-axis, I need you to label that new distance on the x-axis that our wave went to what? Pi. Which means, notice if we go to 2 pi, we have 2 waves. Like we talked about, we should have 2 waves within the old one. But all I need to see is the distance for 1 wave, which you calculated to be pi. Okay? So that's like one big overall example of kind of like the steps that I would go through for finding the characteristics and graphing a sinusoidal function. Okay? Any questions about any of the things I did there? Just make sure you have all this stuff labeled. Yesterday, when I had you graph sine and cosine, a sketch at the end of class, I didn't really check for your period and your minimum and your maximum and stuff, but I want this one labeled for sure. Okay? Alright, so on to the next few examples. We've got 3 right here on the next page to try out with your neighbors, and I'll be floating around to answer questions. Depending on, we get out at 12:05, right? Yeah, at 12:05. So depending on how long this takes us, we might start previewing what happens when I give you the graph and you go backwards and find the equation. We're just going to see how much we have time for, okay? So try these out, super focused. Get some participation points from your neighbor by sharing awesome things with each other. And we'll pick up tomorrow with the same stuff. Yep. Okay, so yesterday we graphed sign. Uh-oh, we didn't finish. And sign generally looks like this when it's just sign of X. There's nothing in front, there's nothing on the inside, there's nothing being added. Okay, so this is the shape of the graph. It starts at the midline, it goes up to the maximum, it goes down to the minimum, and then it comes back to the midline. Okay, so we are taking that graph, since this is sine, and we're doing a bunch of things to it. It's now 5 tall, it's now wide, different width, and it's now shifted to 1. But the general shape should be starting at the midline, going up to the max, down to the min, back to the midline. So we're going to start at our midline, which is now not at 0. Our midline is now at 1. We're going to go up to our max, 6, down to our min, 4, and back to our midline, 1. This shape, kind of like your S, is the same as this one, just transform. That would be if this number 5 was a negative one. It would go down to the minimum and simplify that. Okay, if it's cosine, like you're going to see here, some of them are sine and some are cosine. Cosine does not start at the midline. Cosine starts up at the maximum, goes past the midline, down to the minimum, and back up to the maximum. This is one cycle of cosine. Okay? So when you're drawing this graph later, once you find your midline and all of that, you're going to be starting at the top rather than starting at the middle.
That's the geostat one that starts at the back part.
So when we were at 1, we, from our midline, so we do math from our midline, the next thing we did was the amplitude, and the amplitude is 5, which means our distance from the middle to the top is the amplitude, and the distance from the middle to the top then needs to be 5. So counting from 1 up to 5, we want this to measure with a ruler a distance of 5. And then we want this to measure down a distance of 5. So that's why I do these little groovy things. I counted 1, 2, 3, 4, 5.
Yeah, because it takes energy.
That's why I don't like to do the amplitude first. If you do the amplitude first, you're going to go to 5 and negative 5 and like get confused. Do the midline and then count from the midline up and down. Okay? Yes. Lovely. And so what are you going to label right here? This is your way of the x-axis. This is going to be your pi pi over 2 or 1 pi over 2. Yes. Yeah. The only thing is where you label that. So this usually, let's erase this usually I agree is pi and 2 pi, right? But we changed it because we put a 4 right there. When it's sine of x, this is pi and this is 2 pi. When we put a 4 inside, it means you like squashed it or stretched it. Which means we calculated the period or the cycle of this new function. So this new cycle ends at what? So 1/2 pi is where the first cycle ends, and it starts rotating again. All I need you to label is the period, which is 1 full cycle. You don't need to split it up in any smaller pieces than that. Okay? Whoop.
Yes.
Wow, I'm falling over. Very good.
Oh, she does it.
How are we doing, Johnny? Okay. Pause. Okay. So, what is this and this? Why'd you draw this? Okay, so with the min and max, I agree, for the normal function that we drew yesterday, the min and the max were the same distance from 0 up and down like 1. But with these ones, since we're shifting it all around, remember I said follow the order map, I want you to actually find your midline first when you're putting it on your graph, because then you're going to go up and down from the midline. The midline is going to be your new center of your graph, okay? So let's find all this stuff first using these. Okay, and then once you have these, you'll be able to count up and down your 3. Okay, so your amplitude is this number. Your period is 2 pi divided by this number, your v. So simplify that, you go pi over 2. Okay, your midline is y equals what? -5. So this is what I want you to start with your midline. You're starting down here at -5. Let's just pick a spot for -5. Okay? From -5, the height of our wave, the amplitude, is 3. So we're going to go 3 up and 3 down. So we got a dotted line here at 5. Let's go up 3 to -2 and draw a line. Let's go down 3 to -8 and draw a line. That means this is the new center of our graph, and our wave is now going to bounce between -2 and -8. Okay? And then we're starting here, because it's sine, you start at the midline, you go up to the max, down to your midline. And then it happens over and over and over. But this width right here is what we call what?
But I know like once I grab it, I'm just
That's how the cycle or the periodic nature of the function. So we know that one cycle means we're at pi over 2 on the x-axis at that point. This would be another pi over 2, another pi over 2, and so on and so on and so on. Okay? So what's your minimum? And what's your max? Okay? Does that help? Okay. So, cosine, let's repeat from yesterday. Is cosine straight in the middle? Or did it start at the max? So you're going to start up at 4. You're going to go down past the midline to the minimum, back up past the midline, back up to the max. That's the pattern for cosine. Good. Keep going. So this is perfect, but you haven't completed the full cycle until you get back to where you started. And then it'll just keep doing the same thing. Okay, so this, notice here we didn't put the x in, right? We just picked a 4, so if I have 4x, this is my b. So think about this as kind of like a 1x over 2. So my b is just 1/2, like that. And so you're going to have to flip that fraction. When you divide by fractions, you can multiply times the reciprocal. We're being fancy, so just flip it and then multiply that. Which one? With the b value? Okay. If anyone's kind of like having a question about this x over 2 b value right there for the period on number 2, think about how this is 4 times x and this was your b value, right? So even though this looks kind of like funky, this is just 1x over 2. So your b is just a fraction 1/2. So you've got 2 pi over 1/2, which looks kind of funky. But that's like you might have done in middle school with KFC, or you learned to multiply times the reciprocal and flip it. So this is 2 pi times, not 1 over 2, but 2 over 1, or 2. So we get 2 pi times 2, which is 4 pi. Okay? So that one's kind of weird, but that should help you out with that one a little bit. Give it about another minute to try to finish off maybe that second one. Then we're going to spend our last 2 minutes kind of closing out some thoughts.
No. I already read.
Okay, for this one, 4 pi. Your 4 pi needs to go 1 full cycle, means you need to go all the way back up to the top again. Yeah. Okay, for this one, good. -4 is your A value. This is your B value, and you can just change it to like +2 on this side. And so this is your D value. You just have to rearrange it. Okay, so your period would be 2 pi over pi, so just a nice change.
Yeah, you remember?
So this one's going to start at a full sign. Because it was a -4, it's actually going to go down to the first. Do you have a question? Yeah, I'm going to talk right here. It's not, we're going to rearrange the 2 and put it where we want it, which is on the other side. The 2 is like your main value. It's just they put it
+2?
Yeah. Okay, over here. Last 2 minutes. Bring it back over here for me. I'm going to address one more kind of weird case that came up with some of these as we were talking. This last one, a lot of people are getting to right now, and since it's in a different order, I wanted to put it this way so we can make sure we know how to rearrange it. So everyone we've seen so far has been A is in the front, B is in the inside, and D is added like on the right side of our function, right? But technically, you can add on either side, right? So we need to just rearrange this. I don't want you to be confused with thinking that this is that we're subtracting 2. What this minus is the minus is with your 4, right? That's a negative A value. What's in front of the 2? Technically a positive. So this is the same as -4 sine of pi x plus 2. The negative stays in front of the 4, and the positive stays in front of the 2. Just move it to the other side, and you're back to A, B, and D, normal like we did the last 2 examples. Okay? The period's fun because it goes 2 pi divided by pi, and it's just 2. So it actually makes it like a nice, better number that we even like to label on our graph. It'll go to 2. Okay? Alright, y'all, we will explore this tomorrow and talk about something that we call the phase shift tomorrow.
We learned something about visual effects.
All I want you to do is find the stuff.
Yeah, we learned about.
If you want extra practice, it might be good for you.
Oh, we review about arrays and stuff like that. 1776, you know, easy stuff. Light work. Light work.
You're maturity. This is phase shift.
Yeah.
Here, see if you can go the other direction. We didn't get to that as much today either. Tomorrow we'll build on that. Right?